Hello and welcome. My name is Sean Chassie and I'm a Senior Solutions Architect at AWS. We're going to be looking at artificial intelligence and automation in advertising. Specifically, this demo will focus on intelligent advertising quality control. This demo is designed to provide an overview of how you can streamline your advertising quality control workflow with generative AI. We'll show you how to use a variety of tools to analyze your advertising media and answer the most important quality control issues you might have. Starting with technical quality control analysis, you will be able to identify ads that fail your technical standards, such as frame rate, bit rate, audio clipping, and many more. Next, we will show you how to harness generative AI to identify a variety of quality control concerns, such as taxonomy identification, audience ratings, brand identification, and many more. With this wealth of metadata, you'll be able to move advertising assets through your review pipeline faster than ever before. Let's go see the demo in action. This is the UI for Intelligent Advertising QC. On the left, we have a very simple navigation allowing us to review advertisements and upload new ones. Additionally, we have a link to the Intelligent Quality Control dashboard, which underpins some of the workflow components of the ad QC pipeline. On the right side, we have our main review list. This offers you a view of the assets that have been submitted for processing into the system. For this demo, we only have one asset at the moment. As you can see, a job contains the asset that was submitted. In the future, this could be a combination of multiple assets that are grouped together under a single job. Next, we have the status. The job overall is completed, and our asset has failed one or more checks. The findings column indicates that we have 5 passed and 2 failed findings. Finally, we have the submitted, started, and finished timestamps. Let's take a dive into the asset and see what information was retrieved. Working from the top down, we will step through the main components of the review interface. At the very top, we have the name of the clip, and along the right, we have the ability to approve, reject, or simply return to the main review list. Next, we have some basic metadata about our clip, such as asset ID, the job evaluation status, in this case failed, the file name, when it was submitted, and the review outcome. This will tie into those approve reject buttons at the top. Finally, when the ability to categorize assets is added, the type will show in the last field. Expanding the clip summary, we will take a look at the overall analysis of the asset. We see the transcript here, which is used to pass the audio-based information into the prompts for the LLM. Next, we see that there is one scene and a description, which is a high-level overview of what occurs within the video. Below that is some technical information, such as time, start and end, and frame start and end, for example. Next, we get into the clip detail. This is the generative AI answers that we get back from the large language model. Our first category is GARM taxonomy, and if this advertisement contained any questionable content, a taxonomy identifier from GARM would be seen here. Due to the absence of this, we know that there aren't any brand or safety suitability flags that GARM uses to help assign risk. Next, we have the IB taxonomy, and the LLM selected technology industry for that category, which, if we inspect the IB taxonomy guide, is a Tier 3 category under a Tier 2 category called Industries, which is under the Tier 1 category Business and Finance. Being that this ad is for AWS, tech industry seems appropriate. Next, we have sentiment, which gives us a score of the overall tone of the video, and in this case, it's positive. We have 4 rating categories next: BBFC, FSK, MPA, and USTV, all of which were selected in this case for the broadest audience applicability. Next, we see that we have asked the LLM to identify any brands and logos, and here we see that AWS and Amazon were both identified appropriately. Camera shot embeds, which are next, show us some details as to how the clip can be taken and broken down into specific shots. Finally, we have tags, of which all seem very applicable to our video, which advertises AWS generative AI capabilities. That brings us to the Intelligent QC findings. Here we have findings from the IQC system mentioned earlier. The system combines the outputs of technical quality control with what we are calling compliance quality control to surface a series of findings that give you a rules-based approach to assessing the video itself. Here we have compliance findings at the top. Next is container findings, which pertain to the video's encoding container. After that is video findings, which looks at things such as aspect ratio, bitrate, and so on. Following video, we see audio findings, and the first failure that we have. Moderation findings are next, plus ratings findings, and finally taxonomy findings, which we see 2 of. Going back to the audio findings, we see that there was a finding for audio clipping. Next, we see some informational findings in the form of GARN and IAB taxonomies. Since these do not trigger as bad, they are listed as informational level only. Moving on from the IQC findings, we see what is left of is the frame findings. Here we get frame level data about any of the tasks that have been targeted at this level. For this demo, most all categories besides the rating systems have been targeted. If we expand brands and logos, we see we can group by item or time. Grouping by item shows us AWS and Amazon as these findings. We can expand the AWS and see when it was found. Here we can click on some and see on the video where AWS was identified. Expanding description, we can get a frame-by-frame readout of what is happening throughout the video. Looking at the first one, here we can see it says, the image shows a woman wearing a green camouflage sweater sitting in an office or home setting with the AWS logo displayed prominently. Clicking on this, we can be taken directly to that and verify its accuracy. Next, we see GARM and IAB taxonomy. Here, no identifications in the GARM because it didn't trigger any issues. And then for IAB, we see a series of 6 different categories, and you can expand to see when those occurred. If you switch to time-based, you can see how they overlay with each other or are separate. Next is sentiment. Again, switching to time-based, you can see how the overall sentiment of the clip changes over time, going from neutral to positive back to neutral again. Finally, we have the tags category, and expand that, we see it is grouped by time by default, which is a bit easier to read than the over 100 unique tags that were generated. With that, this wraps up the demo. We hope it was insightful to see the variety of contextual information you can leverage generative AI to provide you within your ads quality control workflow. These categories are just examples of ways in which you can get contextual information out of the LLMs on Amazon Bedrock. With this system, you can configure your own tasks and generate the metadata that is most pertinent to your business needs.